Welcome back, deep divers. Today, we're going deep into the world of autonomous systems.
Fascinating stuff, really.
You know those robots exploring Mars?
Yeah,
Self-driving cars, those deep sea explorers?
exactly. And, what happens when things go wrong?
Oh yeah, because out there, failure is a big deal.
It's not like your computer crashing.
No, we're talking mission critical, right?
Absolutely. Safety hazards, economic impacts, the whole nine yards.
So how do they even begin to make these systems reliable?
Well, that's where fault tolerance and redundancy come in.
Okay, so fault tolerance, break that down for us.
Basically, it's designing a system that can handle failures.
Okay, failures, so we're talking
Hardware malfunctions,
yeah.
software bugs, even environmental stuff you wouldn't expect.
So it's like having a backup plan, but for a robot.
Exactly, yeah.
And redundancy, how does that fit in?
Well, redundancy is key to fault tolerance. Think of it like having a spare tire in your car.
Oh, okay, got it. So you have backup components just in case.
Yeah, so if one fails, the other takes over.
Makes sense. That must give engineers some peace of mind.
Definitely. And there are different types of redundancy, too.
Oh, like what?
So you got hardware redundancy, like having two processors.
Okay.
Software redundancy with multiple versions of a program.
Right.
And then there's information redundancy.
Information redundancy, what's that?
It's like having error-correcting codes, so even if some data gets corrupted.
You can still recover it.
Exactly.
Clever. But let's back up a bit. When we talk about faults, what exactly are we talking about?
Oh, it's not just things breaking down.
Okay, good. Because that would be too simple, I bet.
Way too simple. Faults, they can be hardware issues, like a sensor going bad.
Makes sense.
Software faults, like bugs in the code.
Uh-huh.
Even human errors.
Oh, yeah, people make mistakes.
We do. And those can have big consequences. And then there's environmental factors like extreme temperatures, radiation.
Wow, so it's a whole spectrum of things to worry about.
It is.
It's like a multi-layered challenge.
Exactly. And that's why there are different approaches to dealing with these faults, like fail operational systems.
Okay, fail operational, what's that?
So that's designed to keep working even when something goes wrong.
Even with a fault?
Yeah, maybe at a reduced level, but it keeps going. Think of a plane that can still land even if one engine fails.
Oh, okay, yeah, that's reassuring.
Right. And then you have fail-safe systems.
Fail safe, so that's different.
It is. This is about prioritizing safety above everything else.
So even if it means shutting down.
Exactly. Like the emergency braking system in your car.
Yeah, better to slam on the brakes than crash.
Exactly. And finally, you have fail-silent systems.
Fail silent, so they just stop working.
Yeah, if they detect a fault, they go silent.
But why would you want that?
Well, sometimes it's the best way to prevent the problem from spreading.
Oh, okay, like containing it.
Exactly.
Mhm.
Like a smoke detector. If the battery dies, it stops beeping to avoid a false alarm.
That makes sense. Silence can be golden in those situations. But how do these systems even know something is wrong in the first place?
Good question. That's where fault detection, isolation, and recovery comes in, or FDIR.
FDAR, catchy acronym.
Right. It's like the detective work of keeping these systems running.
So they're monitoring everything.
Constantly.
Yeah.
Checking critical parameters, using sensors to look for anything unusual.
So it's not just about having backups, it's about being smart about it.
Yeah, it's about having a system that can assess the situation and take action.
It's like our own bodies, right? We
Yeah.
have reflexes, self-healing mechanisms.
That's a great analogy.
So it's like taking inspiration from nature.
In a way, yes. And just like our bodies have different responses, these systems have different recovery strategies.
Like what?
They might reconfigure themselves, activate backup systems, or even try to self-repair.
Wow, that's incredible. It's like they're almost alive.
It's getting pretty sophisticated.
So let's bring this to life a bit. Any cool real-world examples of all this in action?
Oh, tons. One of the best is the Mars rovers.
Oh, yeah, they're millions of miles away, working in a crazy environment.
And they've been running for years, overcoming all sorts of challenges.
I remember reading about Curiosity, how it had a software glitch.
Right. And it recovered.
So the redundancy really paid off there.
It did. Curiosity has redundant processors, backup systems, the whole works.
Wow, so it's like having a whole team of engineers on call, but millions of miles away.
Exactly. It takes a lot of thought and engineering to make these things so reliable.
And it's not just space, right? Self-driving cars rely on this stuff too.
Absolutely. Think about all the sensors they have. LiDAR, cameras, radar,
It's like they have eyes everywhere.
pretty much. And they have algorithms to make split-second decisions in case something unexpected happens.
So they can react in real time. That's amazing. But it's not just about preventing catastrophic failures, right? What about keeping things running smoothly, minimizing downtime,
Oh, that's crucial too, especially in places like factories and power plants.
where things need to be up and running 24/7?
Exactly. A fault in one system can cause delays, safety issues, all sorts of problems.
So the stakes are high there too. How did they approach fault tolerance in those settings?
Well, they often use fault-tolerant controllers, predictive maintenance. They're using AI now too.
Oh, AI, of course. Everything is using AI these days. How does that play into fault tolerance?
Well, AI is really good at analyzing data and spotting patterns that humans might miss.
Okay, so it can predict potential problems.
Exactly. It's like having a crystal ball that can foresee issues before they even happen.
Wow, that's incredible. So it's not just about reacting to failures anymore.
No, it's about anticipating them and preventing them. And AI can help make these systems even more adaptable and resilient.
That's pretty mind-blowing. So it's not just about static redundancy anymore.
No, not at all. These systems are becoming much more dynamic and intelligent in how they handle problems.
So what else is on the horizon? What other technologies are going to shape the future of fault tolerance?
Well, there's blockchain.
Blockchain, like cryptocurrency.
Yeah, but it's also about secure and transparent information.
Okay, but how does that apply to fault tolerance?
Imagine using blockchain for communication between autonomous systems.
Okay, I'm following.
So you prevent tampering with data or commands, which is essential for safety. Think about self-driving cars talking to each other.
Yeah, you'd want to be sure those messages are authentic.
Exactly. It's like the nervous system of a fault-tolerant system.
I like that analogy. So we've covered a lot, but I have to ask about the really futuristic stuff.
Yeah.
What about quantum computing? I know it's early days, but I hear it could revolutionize everything, including fault tolerance.
You're right, quantum computing is still young, but it has huge potential.
Mhm.
One of the key concepts is quantum error correction.
Okay, that sounds complicated.
It is, but imagine you're sending a message through a noisy channel.
Okay, I'm with you.
Quantum error correction is like having a special code that not only detects errors, but also corrects them.
So it's like super powered error correction, but on a quantum level.
Exactly. But with all this fancy tech, we can't forget the basics.
Right, the fundamentals still matter.
Absolutely. Rigorous testing, good design, industry standards, those are all critical, especially for safety-critical systems.
Right, because one weak link can bring the whole thing down.
Exactly. It's like a chain, only as strong as its weakest link.
So even with all these advances, we still need to be careful and thoughtful.
Absolutely.
Hmm.
But the future of fault tolerance is about more than just making things stronger or adding backups.
Oh, okay, so what else is there?
It's about embracing new ideas, like adaptive systems and bio-inspired designs.
Adaptive systems, bio-inspired designs. Now those sound interesting. Tell me more.
Well, adaptive systems can adjust their behavior based on the situation,
Okay, so they're like systems that can think on their feet.
pretty much. And bio-inspired designs take inspiration from nature.
Oh, like how living organisms are really good at dealing with damage and adapting.
Exactly. They have built-in self-healing and redundancy.
So we're learning from nature to build better systems.
That's the idea. We're using things like neural networks, which are inspired by the brain.
To create systems that can reroute around damaged areas.
Exactly. And self-organizing systems, which can reconfigure themselves on the fly.
That's incredible. Out of all these developments, what excites you the most?
That's tough. But the potential of these bio-inspired approaches, it's revolutionary. Imagine machines that can learn and adapt, like living organisms, constantly evolving to become more resilient.
That's amazing. It's like we're on the verge of a whole new era of engineering.
We are. And as these systems become more sophisticated and integrated into our lives, the stakes just get higher.
Absolutely. It's not just about keeping the machines running. It's about the impact they have on all of us.
Exactly. We need to make sure these systems are not just reliable, but also safe, secure, and trustworthy.
That's a great point. So where do we go from here? What are the big takeaways?
Well, first we need to think about fault tolerance holistically.
Looking at the whole picture.
Yes. It's not just about adding parts or writing code. It's about understanding the entire system and the consequences of failure.
So we need a multidisciplinary approach.
Exactly. We need engineers, computer scientists, ethicists, policymakers, all working together.
To make sure these systems are developed responsibly. What else?
We need to be open to new ideas.
Like the adaptive systems and bio-inspired designs we talked about.
Exactly. Those, and things like quantum error correction.
To create systems that are more resilient and adaptable than ever before, it's a lot to think about.
It is, but it's also incredibly exciting.
So it sounds like we're on the cusp of a major shift in how we design and build these systems.
We are. And with every challenge comes an opportunity.
That's a great way to put it. So any final thoughts for our listeners today?
I would ask them to consider this. With all these advances, what will the next generation of fault-tolerant systems look like? Could we see machines that not only adapt to failures, but actually prevent them? What does it mean to create systems that might even evolve faster than we can imagine?
Those are some great questions. It really makes you think about the future of technology and its impact on society. Well, thanks for taking us on this deep dive today.
It's been my pleasure.
And to all our listeners, we hope you enjoyed this exploration of fault tolerance. Until next time, keep diving deep.
It can, yeah, think of it like your car alerting you to a brake issue before you even notice anything.
Wow. Like a crystal ball for machines?
Pretty much. And it's not just about predicting failures either.
No.
AI can also help make systems more adaptable, more resilient.
Okay, so how does that work?
Well, it can learn from past failures,
Oh, interesting.
and then adjust how it responds so the system actually gets smarter over time.
So it's like it's constantly improving based on experience.
Exactly. It's not just static redundancy anymore.
It's dynamic. It's learning.
Yeah, it's pretty cool.
It is. It is. So what other technologies are out there, on the horizon for making these systems even better?
Well, there's blockchain, for one.
Blockchain, like Bitcoin and all that.
Right. But blockchain is more than just cryptocurrency.
Okay, so what is it then?
It's a really secure and transparent way to record and verify information.
I see. So how does that help with fault tolerance?
Well, imagine using blockchain for communication between autonomous systems.
Okay.
So you could prevent anyone from messing with the data or the commands.
That's important, especially for safety, right?
Exactly. Think about self-driving cars communicating with each other.
Yeah, you'd want to be absolutely sure those messages are legit.
Absolutely.
No one hacking in and causing chaos.
Exactly.
So we've talked about AI, blockchain, anything else out there that's going to blow our minds. What about quantum computing? I know it's still kind of early days, but
Oh, yeah. Quantum computing. That's a big one.
I've heard it has the potential to revolutionize, well, pretty much everything.
It really does, and that includes fault tolerance.
Okay, so how does quantum computing play into all of this?
Well, one of the key concepts is quantum error correction.
Quantum error correction? That sounds intense.
It uses the principles of quantum mechanics to protect information from errors.
Okay, I'm going to need an analogy for that one.
Okay, imagine you're trying to send a message, right?
Okay, got a message.
But you're sending it through a really noisy channel.
Lots of interference.
Exactly.
Okay.
Quantum error correction, it's like having this special code.
A special code.
Yeah, that can not only detect those errors.
But also correct them.
Exactly. So even with all that noise, the message gets through perfectly.
Wow, that's incredible. So it's like having a super powered error correction system.
That's a good way to put it.
But even with all this amazing technology, we still need to remember the basics, right?
Oh, absolutely. We can't just rely on fancy algorithms and quantum computers to solve all our problems.
Right, like good old-fashioned engineering.
Exactly. Things like rigorous testing.
Making sure everything works properly.
Yeah, and careful design.
Thinking things through from the start.
Right, and following industry standards.
So we're not cutting corners.
Exactly. Especially when we're talking about safety critical systems.
Yeah, where a failure could have serious consequences.
Exactly, because even in the most advanced system, one weak point can bring the whole thing down.
It's like that saying, a chain is only as strong as its weakest link.
Exactly. And that's why engineers spend so much time testing and refining these systems.
To make sure there are no weak links.
Right. But looking ahead, the future of fault tolerance, it's about more than just making things stronger or adding more backups.
Okay, so what else is there?
It's about new ways of thinking, new paradigms.
Paradigms like what?
Like adaptive systems and bio-inspired designs.
Adaptive systems, bio-inspired designs, those sound intriguing.
They are. Adaptive systems can actually change how they behave, based on what's happening around them.
Oh, wow. So they're not just reacting to problems, they're adapting to them.
Exactly. And bio-inspired designs, they take inspiration from nature.
Oh, I like that.
Yeah, because living organisms, they're amazing at dealing with damage and adapting to change.
They have to be to survive.
Right. They have all this built-in self-healing and redundancy.
So we're looking to nature for ideas on how to build better systems.
Exactly. We're using things like neural networks,
Yeah.
which are inspired by the brain.
You create systems that can, reroute around damaged components.
Exactly. And self-organizing systems,
Which
too.
can, reconfigure themselves on the fly.
Yeah, it's pretty amazing stuff.
It is. It is. So out of all of this, all these amazing developments, what stands out to you as the most exciting?
Oh, it's hard to pick just one, you know? But the bio-inspired stuff, that's really got me thinking.
Yeah, the potential there is huge.
Imagine machines that can learn and adapt like living things.
It's almost like they're alive in a way.
In a way, yeah, constantly evolving, becoming more and more resilient.
It's a whole new level of engineering, isn't it?
It is. And as we integrate these systems more and more into our lives, the stakes get even higher.
Absolutely, yeah. It's not just about keeping the machines running anymore. It's about, the impact they have on us.
Right, exactly. We need to make sure they're not just reliable, but safe.
Secure, too, right.
Absolutely. And trustworthy. We need to be able to trust these systems.
That's a big one. So where do we go from here? What are the key takeaways from all this?
Well, I think, first of all, we need to think about fault tolerance holistically.
Holistically, okay, so what does that mean?
It means looking at the big picture.
Not just focusing on one little part.
Right. It's not just about adding redundant parts or writing better code. It's about understanding the entire system.
How it interacts with everything else.
Exactly. And the consequences if something goes wrong.
So we need to think about the ripple effects.
Exactly. It's a systems thinking approach.
So it sounds like we need more than just engineers working on this.
We do. We need computer scientists, ethicists, policymakers, everyone.
Working together from the start.
Exactly. To make sure these systems are developed responsibly. And second, we need to be open to new ideas.
New ways of doing things.
Yeah. We can't just rely on the old methods. We need to explore these new paradigms.
Like the adaptive systems and bio-inspired design.
Exactly. And things like quantum error correction.
To create systems that are more resilient, more adaptable than we've ever seen before, it's exciting, but also a little bit daunting to think about all of this.
It is. But it's a challenge worth tackling.
Absolutely. It sounds like we're really on the cusp of a major shift in how we design and build these systems.
We are. And with every challenge comes opportunity.
That's a great way to look at it. So, any final thoughts for our listeners today?
I would ask them to consider this. With all these advances, what will the next generation of fault-tolerant systems look like?
Oh, that's a good one. What will they look like?
Could we see machines that not only adapt to failures, but actually anticipate them?
Wow, prevent them before they even happen.
Exactly. What are the implications of creating systems that might even evolve faster than we can imagine?
That's a really thought-provoking question. It really makes you think about the future of technology and its impact on all of us, on society. Well, thank you so much for taking us on this deep dive today. It's been fascinating.
It's been my pleasure. I always enjoy exploring these topics.
And to all our listeners, we hope you've enjoyed this exploration of fault tolerance as well. Until next time, keep diving deep.